Hello everyone. So today we're going to go over section 6.3 part B, Trigonometric Ratios. Recall that if r is equal to 1, then we have sine theta is equal to the y-coordinate on the unit circle. Cosine theta is equal to the x-coordinate. And tangent theta is equal to y over x. So we know that in quadrant 1, both x and y are positive. In quadrant 2, x is negative but y is positive. In quadrant 3, both x and y are negative. And finally, in quadrant 4, x is positive and y is negative. So, combine that with what we know about the reciprocal trigonometric ratios, and that is, for example, cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And that cotangent is equal to 1 over tangent theta. We know the following. In quadrant 1, sine theta and therefore cosecant theta will be positive because the y-coordinate is positive there. Likewise in quadrant number 2. In quadrants number 3 and 4, however, both sine theta and cosecant theta will be negative. So for cosine, we know that once again in quadrant 1, it will be positive, cosine theta and secant theta. In quadrant 2, they will be negative. In quadrant 3, again, they will both be negative. And finally, in quadrant 4, because the x values are positive there, so will cosine theta and secant theta be positive. And next we have tangent and cotangent theta, and that will be positive in quadrant 1, negative in quadrant 2, because one of x and y is positive, the other being negative, so the ratio will be negative. In quadrant 3, since both x and y are negative, the quotient there will be positive. And finally, in quadrant 4, x is positive but y is negative, so the quotient will be negative there. So to summarize the result of all 4 of these, we know that all 6 of the trig ratios will be positive in quadrant number 1. In quadrant number 2, only sine and cosecant will be positive. In quadrant number 3, only tangent theta and cotangent theta will be positive. And finally, in quadrant 4, only cosine theta and secant theta will be positive. And a mnemonic device for this is CAST. So starting with quadrant 4, we have C, A, S, and T. An alternative to that is starting with quadrant 1, all students take calculus, and that's a nice way of remembering that which trig ratios are positive in which quadrants. Okay, so with that in mind, we can now find the value of all 6 trigonometric ratios for a given angle in exact values, provided that the angle in question are related to special triangles. So here we have theta is equal to 5 pi over 6. So one way of working with this question is to consider that 5 pi over 6, if we multiply by 180 degrees and divide by pi, that will give us 150 degrees. So as always, we can work with degrees instead of radians, if that's easier. So the reference angle in this case is 30 degrees, or pi over 6. So for now, we're just going to stick with radians. So this angle here going in the counterclockwise direction is 5 pi over 6. The reference angle is pi over 6. And of course, we can use the pi over 6, pi over 3 special triangle. Sorry, the pi over 6, pi over 3, pi over 2 special triangle. Just going to go ahead and draw that in here. We have a right triangle. We know that the y value here will be positive 1/2, and that the x value, because it is in quadrant 2, will be negative, and that it will be negative √3 over 2. Okay. So, of course, the hypotenuse or the radius is 1. So now we have that sine theta is equal to the y value, which is just 1/2. And cosecant being 1 over y is going to be equal to 2. Cosine theta is the x value, which is in this case negative √3 over 2. And then the secant theta value will be 1 over x, which of course is negative 2 over √3. Tangent theta is y over x. So that will be negative 1 over √3. And cotangent theta was x over y, or we can just take the reciprocal of the tangent theta value that we already found. So that will just be negative the square root of 3. So notice here that just as we stated before here, that in quadrant 2, only sine theta and cosecant theta should be positive, and our 6 trigonometric ratios here do match that. So sine theta and cosecant theta are positive, whereas cosine, secant, tangent, and cotangent theta are all negative. Let's try another one. Okay, so we have theta is equal to 5 pi over 3. So that is going to be in quadrant number 4, like this. So it is pi over 3 short of 2 pi. So if we were to draw the angle, just like in the previous question, going counterclockwise, this would be 5 pi over 3. And then here, this is pi over 3. Sorry, yes, that's right, pi over 3, going in the opposite direction to make the reference angle. It's going to go ahead and draw in the right triangle once again, using our dash lines here. So something like this. Okay. So once again, we're working with the pi over 6, pi over 3, pi over 2 triangle. We have the hypotenuse or the radius being 1. This length will be negative √3 over 2. And the x value is going to be 1/2. Okay, so we are in quadrant 4. The x value is positive. The y value is negative. And so the exact values of our trig ratios will be, starting with sine theta, negative √3 over 2, since it is in quadrant 4, so y value is negative there, and therefore sine theta and cosecant theta are negative. Next, we have the cosine theta and secant theta values. These will be positive, so in this case 1/2 and 2 respectively. And finally, the tangent ratios and cotangent ratios, these will be negative, and the first will be negative √3, and cotangent theta in this case will be negative 1 over √3. Okay, so let's move on to example number 2, which asks in which quadrant will theta terminate if angle theta is in center position with the given conditions. So in this first case, we have that cotangent theta is greater than 0. And if we check at the top of the page, we know that in quadrant 1, all trig ratios are positive, and that in quadrant 3, tangent theta and cotangent theta are positive. Okay, move on to part B. We're looking for the trig ratio of cosine theta to be positive, so this will be either quadrant 1 or 4. And then cotangent theta being negative, this will be quadrant 2 or 4. So combining these two means that the only quadrant that works will be quadrant 4. Next up, we have sine theta being positive and secant theta being positive. So this is going to be 1 and 2 for sine theta to be positive. Secant theta being positive, that's quadrants 1 and 4. So the only one they have in common in this case is quadrant 1. And finally, secant theta being negative, that's quadrants 2 or 3. Tangent theta being negative, that's quadrants 2 or 4. So combined, then here we have quadrant 2. Okay, so the next part is to find angles given the trigonometric ratios. So, for example, we have in example 3a, tangent theta is equal to -1, so we're to find where that angle is. So the first step here is to determine the quadrant or quadrants where the angle will be in by looking for the sign of the ratios. For example, tangent theta being -1 means that we can have either quadrant 2 or 4. So there's two possibilities. The second part is to determine the reference angle and draw a rough sketch in the appropriate quadrant or quadrants. And then finally determine the rotational angles. Okay, so in order to do this, we'll need the special triangles. Let's go ahead and draw these here really quickly. The first special triangle is the 45, 45, 90 triangle, or the pi over 4, pi over 4, pi over 2 triangle. Okay, so here we have it. So let's just go with the degree measures. 45, 45, 90. And the three sides are, the hypotenuse will be 1, and the two legs will be 1 over root 2 and 1 over root 2 respectively. The second special triangle, the 30, 60, 90 triangle, or the pi over 6, pi over 3, pi over 2 triangle. Just going to go ahead and draw that here. Okay, so here we have 90, 60, and 30 respectively. Let's go ahead and add those in. And we know that the sides are 1, and then the length opposite the 30 degrees is going to be 1/2, and the length that's opposite 60 degrees will be the square root of 3 over 2. So going back to the first question here, we're looking for the tangent ratio to be equal to -1. And the only way to get that, we have to have y and x be equal to each other. So we must be working with the 45, 45, 90 triangle. As we can see here, both of these will be 1 over root 2, so their quotient is going to be just 1. That is to say, our reference angle will simply be 45 degrees. Now we are going to be in quadrants 2 or 4, so the way that we're going to draw our angles is this way. Let's go ahead and draw in the triangle. So we have either 135 degrees, or we will have 315 degrees. So going this way, I guess, 315. So the steps again: quadrants 2 or 4. Step 2, the reference angle, which is to be found using the special triangle as we did. We know the reference angle is 45 degrees. So here we have 45 degrees in quadrant number 2 and 45 degrees in quadrant number 4. So that means that the angle theta must be equal to either 135 degrees in quadrant 2 or 315 degrees in quadrant 4. Okay, so that's the steps. Let's look at the second one. Here we have example 3b. So we're looking for cosine theta to be positive, so that is going to be either quadrant 1 or quadrant 4. The reference angle in this case, if we are looking at our triangles, we're looking for the adjacent over hypotenuse to be root 3 over 2, so we must be looking at 30 degrees and root 3 over 2 here. So the reference angle is 30 degrees. So that's step number 2. Theta r is equal to 30 degrees. Okay, so from there we can draw in the 30-degree angles, reference angles in both quadrant 1 and quadrant 4, like so. So in quadrant 1, the reference angle being 30 degrees means we just have 30 degrees. And in quadrant 4, if the reference angle is 30 degrees, then the actual angle is 330 degrees. So our two answers for this example are 30 degrees in quadrant 1 and 330 degrees in quadrant 4. Okay, so next up, cosine theta. So again, same kind of thought process. Cosine theta being negative, that will be in quadrants 2 or 3. So that's step 1. Step 2 is to determine the reference angle. So notice that in this example and the next, we are working in radians. So therefore, we should list our reference angle in radians in this case. We're looking for cosine. Again, that will be adjacent over hypotenuse to be 1/2. So the reference angle must be 60 degrees or pi over 3. Okay, so from there we draw in, once again, the angles, pi over 3 in quadrants 2 and 3 respectively. So here we have the reference angle of pi over 3 going in both of these directions here. So the first angle will be 2 pi over 3. Sorry about that. Okay, so that's pi over 3 short of pi. And then the second angle will be going this way, and that will be 4 pi over 3. That will be pi over 3 more than pi. So the two answers for theta will be 2 pi over 3 or 4 pi over 3. Sorry about that. Okay. Last example of this type, cotangent theta equals -1. So we're looking at, in this case, where cotangent and also tangent theta will be negative, so that's either quadrants 2 or 4. Okay, step 2 is to find the reference angle. So just as before, if we have a tangent or cotangent ratio of 1 or -1, that means the x and y values are equal to each other. So that only happens when our reference angle is 45 degrees or pi over 4 in radians. So we are once again drawing a line this way. So the answers are same as in part A, but this time they will just be in radians. So the first one of which will be 3 pi over 4. and the second of which will be 7 pi over 4. Okay, so that's that part. Next up is the same kind of idea, but we're going to use the calculator. Notice that in example 4, sine theta is equal to 0.42, and we have also cotangent theta is equal to negative 4.87. Those are not special triangle values. So what we're going to do is use the calculator function. I'm just going to write this in a different color though. So theta is going to be equal to arc sine 0.42. Now this is going to give us the quadrant 1 answer of 0.433. Again, that is approximated. We rounded here. And this is in quadrant 1. However, we know that sine theta is positive in quadrant 1 and quadrant 2. So to find the quadrant 2 answer, we need to use the answer that we got as a reference angle. And so here we're going to have pi minus the 0.433 that we got from the calculator, which gives us a second answer, the one that's in quadrant 2, 2.709. Okay. So next one, cotangent theta is equal to negative 4.87. So the first thing we're going to do here is we're going to use the fact that cotangent theta is equal to 1 over tangent theta. So we'll start there. That means we can solve for tangent theta. Tangent theta is going to be, of course, equal to negative 1 over 4.87. Like so. Now, tangent theta is negative in quadrants 2 and 4. So what we are going to do here is start by finding the reference angle. So we're going to do theta r is equal to arctangent of positive 1 over 4.87. And what this will do is give us the reference angle that we need, because we know that the answers are actually in quadrants 2 or 4. So once we have done that, we know that the approximate value of the reference angle is 0.203. So from there, the first answer is going to be the quadrant 2 answer. And that will simply be pi minus 0.203, which is going to be approximately 2.939. We also have a second answer that's going to be in quadrant number 4, and that's going to be 2 pi minus the reference angle of 0.203, and that's going to give us approximate value of 6.080. Okay, and the reason that we subtracted here is if we, let's say for example, consider just using this diagram above, we know that the angle is somewhere in quadrant 2, and we know that what the reference angle is, and we know that this line is pi, so we're going to subtract the reference angle from pi to get the actual angle. And then the same thing in quadrant 4, we know that the angle is somewhere in quadrant 4, and this is the reference angle here, so we're going to go 2 pi minus the reference angle to get the angle that we need. So in case it wasn't clear why we're subtracting the reference angle from pi and 2 pi. So the only other case is if the actual angle is in quadrant 3, something like this, then we will take the reference angle and add that to pi to find out what this angle actually is. So to summarize, if the angle is in quadrant 1, then we just use the calculator to find the in an arc, sine, cosine, or tangent to find the trig ratio. If it's in quadrant 2, then we find the reference angle and then we subtract it from pi. If it is in quadrant 3, we find the reference angle and add pi. And finally, if it's in quadrant 4, we find the reference angle and then 2 pi minus that reference angle to get the angle that we need. So we have one more example. Example number 5. The point A, -4, 3, lies on the terminal arm of an angle theta, and we're looking for the all 6 trigonometric ratios. So the first thing we're going to do is draw in -4, 3, which is going to be in quadrant number 2, and it is going to be wider than it is tall, since 4 is greater than 3. Go ahead and draw that in. So we know that the x value here is going to be -4. The y value will be 3. And we can use the Pythagorean relationship to find out what r is in this case. So we have -4 squared plus 3 squared is equal to r squared. So we have 16 plus 9 is equal to 25. Oh, sorry, yeah, it's equal to 25, which is equal to r squared. So, of course, then r is equal to 5. So now we have the x value, the y value, and the r value. We can find the 6 trigonometric ratios. Sine theta is equal to y over r. So that's going to be 3 over 5. Cosine theta is equal to x over r. So that's going to be -4 over 5. And then tangent theta is equal to y over x. And that will be -3 over 4. Now, of course, we also have the reciprocal trig ratios, so cosecant theta. And we can simply take the reciprocal of the sine ratio, so we have 5 over 3. Secant theta, we take the reciprocal of the cosine ratio, so -5 over 4. And finally, cotangent theta, we can take the reciprocal of the tangent ratio, so we have -4 over 3. So that's all 6 of the trigonometric ratios, and that also concludes this section 6.3 part B. Thank you for listening.